Right now, a set of clocks in space are ticking faster than the watch on your wrist. And if nobody corrected for that, the little blue dot on your phone would be lost inside 2 minutes. You used it today to find a street, a car, a coffee shop. GPS feels boring precisely because it just works. But hiding inside that little blue dot is the most famous physics of the last 100 years, running quietly in your pocket. To see why, we have to ask a simpler question first. How does your phone know where you are at all? Here is the thing that surprises people. Your phone never talks to the satellites. It only listens. High above you, a fleet of about 30 satellites is constantly broadcasting one message. I am here, and the time is exactly now. Your phone catches those messages and checks how long each one took to arrive. That is the whole trick. It isn't magic, it is a stopwatch. Think of each satellite as a lighthouse, shouting the precise time. Because the signal travels at the speed of light, a known speed, how long did it take to reach me becomes how far am I from that lighthouse? Catch 4 of them, and there is exactly one spot on Earth that fits all 4 distances. That spot is you. Trilateration. Fancy word. Simple idea. But look closely at what we are really measuring. Time. And light is fast. Absurdly fast. It covers about 30 centimeters in a single nanosecond. 1 billionth of a second. So if a satellite's clock is off by just a few billionths of a second, your position is off by meters. To keep GPS accurate, those clocks have to agree to within about 20 to 30 nanoseconds. This system does not want good clocks. It demands almost perfect ones. So they use atomic clocks, the best we build. Problem solved, right? Except when engineers actually ran the numbers, something was wrong. The clocks up in orbit refused to stay in sync with the clocks on the ground. Not because they were broken, because of where they were and how fast they were moving. This is where Einstein walks in. Einstein's first big idea, special relativity, says the faster you move, the slower your clock ticks compared to someone standing still. And these satellites are moving, about 14,000 kilometers per hour, so their clocks fall behind ours. By how much? About 7 microseconds every day. If that were the whole story, the satellites would run slow. But it is not the whole story. Einstein's second idea, general relativity, says gravity slows time too. The stronger the gravity, the slower your clock. Down here on the surface, we are deep in Earth's gravity. Those satellites, 20,000 kilometers up, feel much weaker gravity. So their clocks tick faster than ours. And this effect is bigger, about 45 microseconds a day. Now add the two together. Motion pulls the satellite clock 7 microseconds slower. Weak gravity pushes it 45 microseconds faster. Gravity wins. The net result, every clock in the GPS fleet runs about 38 microseconds per day faster than your clock on the ground. That sounds like nothing. 38 millionths of a second. Who could possibly care? Your phone cares. Remember, this system counts in nanoseconds, and 38 microseconds is 38,000 nanoseconds. Left uncorrected, the errors would pile up by about 10 kilometers a day. Your blue dot would slide off your street, off your town, into a field. So the engineers did something wonderful. Before launch, they set each satellite clock to tick slightly slow on the ground, so that once it reaches orbit, where time really does run faster, it speeds up into perfect agreement with Earth. They corrected reality with Einstein's math. Sit with that. Every time your phone finds you, it is silently accounting for the fact that time itself flows at different speeds for you and for a satellite. Relativity is not a chalkboard abstraction. It is a setting dialed into hardware. keeping you from getting lost. GPS proves Einstein right, quietly, about 38 microseconds at a time, every single day. So the next time that calm little voice says, "Turn left in 300 meters," you can smile, because you know the secret. It is not just a map. It is 100 years of physics working for you. If you like the feeling of the world getting a little less mysterious, subscribe. One complex idea made simple every week.